Hello students, അടുത്തതായിട്ട് നമ്മൾ സൈൻഡ് കർവേച്ചർ, ടോട്ടൽ സൈൻഡ് കർവേച്ചർ എന്നുള്ളൊരു കൺസെപ്റ്റ് ഡിഫൈൻ ചെയ്യാനാണ്. സോ ഡെഫിനിഷൻ so signed curvature that will vary from point to point. Suppose that this is the curve. At this point there is a signed curvature. At this point there is another signed curvature. And suppose the particle continues its motion like this. Then at this point its signed curvature will be additive inverse of the signed curvature at this point, because at this point the tangent vector rotates counterclockwise. The tangent vector rotates counterclockwise like this. While at this point, what happens? The tangent vector rotates clockwise. This is how tangent vector rotates. So at this point, the signed curvature will be negative of this quantity, provided their magnitudes are the same, of course. So total signed curvature may be 0. For example, if a curve has equal negative signed curvature and equal positive signed curvature at different points, then total signed curvature will be 0. So how do I define total signed curvature? So total signed curvature of a plane curve is defined as, so let us assume curve is closed plane curve. Closed means what? Periodic. Closed means periodic. Plane curve, and that is of unit speed. Of unit speed is defined as periodic of period L. Closed means periodic of some positive period, let it be L. And for a closed periodic curve of period L, what is its length? Recall what is length? Length is equal to, so periodic means gamma of L plus S is the same as gamma of S for all S, and length is defined as, that means after L length of the parameter S, the curve again repeats. So length can be defined as integral 0 to L norm of gamma dot of S ds, but gamma is of unit speed, so gamma dot of S norm is equal to 1, so this is integral 0 to L ds, so this is simply L. So for a periodic curve of period L, length is equal to the period. Length equal to period. Okay. And the total signed curvature is defined as integral over its length. What is length? Period. Integral 0 to L Ks ds, where Ks is the signed curvature at the point S. So it is given by this integral, where L is the period of gamma or the length of gamma. this curve is not closed. For closed curves, we are defining total signed curvature. So this figure may be not appropriate here, may not be appropriate. So let me remove this. We will prove a proposition. The total signed curvature is an integral multiple of 2 pi. Integral multiple of 2 pi. So to prove this, assume L is the length of gamma, that L is equal to length of gamma, where gamma is unit speed. What I have to show? Total signed curvature is integral multiple of 2 pi. So total signed curvature by definition equal to integral 0 to this length L kappa s ds, but the kappa s is d phi by ds, where phi is the turning angle, right? So by fundamental theorem of calculus, this is what we proved in the last class. Kappa is equal to d phi by ds. So by fundamental theorem of calculus, this is phi of L minus phi of 0. Okay. Now gamma of t, gamma dot t equal to cosine phi t. Let me remove this t and use the letter s. Gamma of s is gamma dot of s equal to cos phi s comma sin phi s. And gamma is periodic with the period L. So gamma of s plus L equal to gamma of s for all s in alpha beta let us differentiate both sides with respect to s. And I want to compute the derivative at the point s plus L. Gamma dot of s plus L, let us compute. So this is limit h tends to 0, gamma of s plus L plus h minus gamma of s plus L divided by h. Okay, this is equal to limit h tends to 0. Gamma is periodic of period L. So gamma of s plus L plus h is the same as gamma of s plus h minus gamma of s plus L is the same as gamma of s divided by h, which is equal to, what is this? This is precisely the derivative of gamma at the point s, gamma dot of s. So gamma of s plus L equal to gamma of s implies that, by after differentiation, it will imply that gamma dot of s plus L is the same as gamma dot of s. Understand? So now what we do is I will evaluate gamma dot at the point 0 and gamma dot at the point L from this expression. So this is star. So from star, let us take another window. Gamma dot of 0 equal to cos phi 0 comma sin phi 0, and gamma dot of L is cos phi of L comma sin phi of L, but what we have observed, gamma is periodic of period L. So gamma of L is the same as gamma of 0. That will imply that after differentiation, gamma dot of L is the same as gamma dot of 0 because of the periodicity of gamma. So you can have these two equal. Thus, the right side are equal. So cos phi L comma sin phi L is the same as cos phi 0 comma sin phi 0. When two vectors are equal, if and only if their first components are equal and the second components are equal. So cos phi L equal to cos phi 0 and sin phi L equal to sin phi 0. Then what is the relation between phi L and phi 0? This implies that phi L minus phi 0 is 2k pi for some integer k. But what is phi L minus phi 0? From the previous slide, phi L minus phi 0 is, what is that? Yes, phi L minus phi 0 is precisely the total signed curvature. So total signed curvature is an integral multiple of 2 pi. Integral multiple of 2 pi. Thank you.